Hello guys, and welcome to another video. On this video we'll be again looking at Newton's law, and this question is from the November 2023 final exam paper 1. Let's get into it. So here our statements reads that we have two blocks, A of mass 4 kg and B of mass 9 kg, which are connected by a light inextensible string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. Then they say a constant force F acting parallel to the plane is applied to block B as shown in the diagram below. The blocks now accelerate up the plane at an acceleration of 2 meters per second squared. Okay. Then 2.1 says state Newton's second law of motion in weights. So this law, guys, talks about a net force, right? And that net force will be applied to this object, or rather a certain object. And when that happens, we will have our object accelerating in the direction of the net force, where acceleration is directly proportional to that net force and inversely proportional to the mass. But like I said, I want us to use the exam guideline to give that definition. So let's check it out. This is our definition, this highlighted one. As you can see, it says that when a net force acts on an object, by the way, this is Newton's second law of motion. When a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration will be directly proportional to the force and inversely proportional to the mass of the object. So that is Newton's second law. And as you can see, guys, we also have here Newton's first law. So you can pause the video and just look at these laws. Okay. And yeah, let's now move on to the next question. That was for the definition of Newton's first law. Now, for the second question, they say that the kinetic frictional forces acting on blocks A and B are 5,88 newtons and 13,23 newtons respectively. Then they say draw a labeled free body diagram showing all the forces acting on block A. And here we have 4 marks. And remember what we said. We said that the number of marks indicate the number of forces that are supposed to appear on your free body diagram. Okay, so the block that we are being asked to draw a free body diagram for is this one, the 4 kg block. So that's what I'm going to do. But I will also draw the free body diagram of the 9 kg block for your convenience, guys. Okay, because we are revising after all here. So this is what I'm going to have. I'm gonna have my 4 kg block like that, and since it's on an incline, this is how it's going to be. And you will realize that on this 4 kg block, the first force, the visible force, I say when you draw your free body diagram, you look at the number of marks, and most of the time the number of marks will tell you how many visible forces you have and how many invisible forces you have. So the 4 marks in terms of the 4 kg block tell me that I have 1 visible force, and then I also have 3 invisible forces. Okay, the 1 visible force is the force that is on the string, and that is my tension force. So when I have my tension there, then I have my 3 invisible forces. The first one that I have, the normal one, will be my force of gravity, or you could say your weight. The other force that we will have is, okay guys, these are supposed to be straight, but because I'm not using a ruler here, it's gonna look a bit funny. The other force I'm going to have, obviously, is the one that opposes the motion of this object, and that is my force of kinetic friction. Then I will also have my normal force. Okay, that's the other force that I'm going to have, my normal force. And these guys are the forces that I have. And as you can see, I have 1, 2, 3, 4 forces. Remember I said if it's 4 marks, it means 1 force is visible, the other 3 are invisible, meaning we can't see them. T is the one that we see here. Okay, that is T. Fg, N, and Fk are not seen. They are not indicated here. Okay, so this is the free body diagram, the one for block A. Okay, this is for block A. Let's do block B. So for block B, guys, what you will realize is that, let me raise here. What you will realize for block B, guys, is that block B would be worth 5 marks. If you're drawing for the 9 kg block, you would have 9 marks. And if I'm drawing my free body diagram for this one, I would have two visible forces, which is force F and this tension force here. So my free body diagram would be like this. This would be my F. Then I would have my T, which is my tension here. Then I would have my Fg there. Then I would have my normal force. And then the other force that I would have is what? The force of kinetic friction. Okay, so this is how my free body diagram for the 9 kg block would look like. But yeah, the one we were focusing on is this one for block A. Now we move on to the next question. The next question, guys, says we have to calculate the magnitude of the tension in the string. Okay, so we want the tension here in this string, or rather on this string. For us to find that, guys, we will have to check the information that we have. Okay, and the information we have is the kinetic friction of what? Of block A. Okay, and then we have other things that we can find, okay, from our free body diagram. What we will find on our free body diagram is that the tension we are looking for is this one. Then we have the force of kinetic friction, but there are other things we can add to this free body diagram. But guys, these forces that we are going to add here, we are not going to add on the free body diagram that we have been asked to draw. Okay, the one that we've been asked to draw should not have these forces, and these forces are called the component forces. Okay, so my first component force would be like that, and it would be Fg perpendicular, right? And the other component force I would have is this one here, which we would call the Fg parallel, right? So when I'm answering this question, I'm gonna focus mainly on these forces that are horizontal. Okay, and how many forces do I have there? I have 3 forces. I have the tension force, the force of kinetic friction, and the perpendicular force of gravity, or rather the parallel component force of gravity. Okay, so those are the forces that I'm going to have that will help me find this tension in the string. Okay, so I'm just gonna erase this part here to have enough space. So to answer 2.3.1, this is how we are going to do that. We are going to say, okay, F net here is equal to MA. Okay, we are going to say F net is equal to MA. And then we are going to substitute. Remember, guys, F net means that we are adding all of the forces, right? F net is the total number of forces, or rather the total number of forces that are acting on this object, which are making it to move. All right, so the forces that are making this object to move, or are pulling this object in size that will make it move, are the tension force, the kinetic friction, and the force of gravity, which is the parallel component force. Okay, I'm not parallel, the gravitational component force, which is parallel. Okay, so when we break this down, our F net will say we have how many forces? We have 3, which is T, this one here. Then we will have our kinetic friction, and it's going to be negative because it's going in the opposite direction. We will also have our Fg parallel, it will also go in the opposite direction. Then our M is the mass of our block, and the block is what? 4 kg, so we have 4 there. What about our acceleration, guys? If we go back to the statement, we'll remember that they had given us our acceleration, and the acceleration is that one there, which is 2 meters per second. So we're gonna write 2 there. Then from there we'll substitute further here. Tension is what we want. Do we have our kinetic friction? Yes, we do. It's this one. I will also highlight it. Our kinetic friction, guys, is that 5,88. So I'm gonna write that down here, 5,88 minus FG parallel, guys, can be broken down into what? FG parallel is equal to mg. It's going to be mg sine theta. Okay, so where I see, and I know mg is what? Is the mass multiplied by the gravitational acceleration. So here I'm just gonna substitute. My m is the mass of the 4 kg block, or block A, which is 4. Then g is 9,8. Then I will have sine, and for the theta, I have this angle there, which is 35 degrees. Okay, let me just write it properly for you to see, because I don't have enough space here, guys. Let me try and make some space. Just gonna, okay, let me put my minus there, and then FG, remember we said it's gonna be mg sine theta, so that's m, which is the mass, that is 4. Then 9,8 is my g. Then I will have sine 35 degrees. All of this will be equal to what? 4 times 2, which is equal to 8. Okay, then from there we solve for t, and that means I'm gonna take all of this. Let me highlight it. Let's use green this time. So this means, guys, that I'm gonna take all of this and put it on my calculator. You see all of the stuff that I've highlighted in green. I'm gonna take it and put it on the calculator. So let's do that. That means I'm going to have t, then let me press my calculator. When I say minus 5,88 minus open bracket 4 close bracket, and then open another bracket 9,8 close the bracket, and then write sine 35, then press equal to. Yeah, so I'm seeing minus, okay, my calculator is giving me an error, but now everything's okay. So the value, guys, I get when I put all of this that I've highlighted in green on the calculator, I get a value of t minus 28, I'm just gonna round this off to 2 decimal places. 28,36 is equal to 8, and then this will be brought to the other side. And when we take it to the other side, it means it's going to be positive. So that means I'm going to have 8 plus, when I take this to the other side, it's going to be 28,36. Therefore, t will be equal to 8 plus 28,36. So that means my answer will be 36,36 newtons. So that's my t. Okay, I hope, guys, it makes sense. So the first thing we did was to write down F net is equal to ma, and then F net is us writing all the forces that are acting on our 4 kg block, which is the tension force. Let me just show you our tension force, our kinetic friction, and our FG or rather FG parallel, perpendicular. Then from there, guys, we do the math. Okay, done with this question, we move on to the next one. Okay, for the next one, they say we have to calculate the magnitude of force F, and this is worth 3 marks. So, guys, this is how we are gonna answer this one, which is 2.3.2. We are gonna use the same logic. Okay, let me erase the free body diagram of this one and draw the free body diagram of the 9 kg block. Wish I hadn't erased it. Alright, guys, so when I draw the free body diagram of the 9 kg block, remember I said we would have F, then we would have our tension there, then we would have our FG, then we would have our FK, we would have our FK. Okay, let me just fix here. We would have our FK there, and then we would also have our normal force. Okay, but for us to answer this question, we need to add two other forces, and we call those the component forces. I'll use a different color for the component forces this time. Let's use this one. So when we have, okay, that is too light. Let me find it darker. Orange is better, I think. So when we draw our component forces, guys, we will have this component force, which is again the FG perpendicular, and then the other one that we'll have will be FG parallel. The same thing we did with the other block A. So here the forces we are focusing on again are these ones here. And how many forces do we have here? We have 1, we have 2, and we have 3, and we have 4. So in this case, for block 9, for the 9 kg block, which is block B, we have 4 forces, okay, that are making this object to move on either direction. So that means we already have this formula. So what we are going to do there is to say F net is equal to MA again, and then from there, what is F net in this case? We are adding all of these forces, and this one, guys, will go in the positive direction, then these 3 forces will go in the negative directions. Okay, so that means here I'm gonna have F, which will be positive, minus T minus FK minus FG parallel. All of this will be equal to MA, and then I'll substitute here now. I'll have F minus, what is my T? My T is this one that I found here, guys, remember, and that's going to be 36,36 minus this FK. When I read my statement, they told me that blocks A and B have the kinetic frictional forces of what? Of 5,88 and 13,23. So the kinetic friction for block B is this one here. Okay, let me highlight it. The kinetic friction for block B is the one that I've highlighted in green. Okay, so that means here I'm gonna put 13,23 minus this one, guys, remember, is equal to that, and that means I'm just gonna substitute here my mass, the mass of what this time? I'm dealing with the 9 kg block, so I'm gonna put 9 there, multiplied by 9,8, and then I will write sine 35, and all of this will be equal to what? All of this will be equal to the mass of block B, which is 9, multiplied by the acceleration, which is 2. Okay, then from there I'm moving on now to the next step. My next step will be to put what I've highlighted. Let's use color yellow. So my next step is to put this part, all of this that I'm cycling in yellow, on the calculator. Okay, I'm gonna put all of that on the calculator as it is. All right, so that means when I proceed here, I will say F, then find out what this is on the calculator. So what I'm gonna do on my calculator, I hope you are doing this as I'm doing it too. I will say negative 36,36 minus 13,23 minus open bracket 9, close bracket, and then open another bracket 9,8, and then I will close my bracket and then type press sine 35, and then close the bracket and say equal to. So the value I get when I put all of these, guys, that I've cycled in yellow on my calculator is negative 100 comma 18, okay, is equal to, and then here I have 9 times 2. Remember, this is 9, the mass of block B. 9 times 2 gives me 18, and then I will take this negative 100 comma 18 to the other side. That means I'm adding it. When I bring it to this side, that's going to be 18 plus 100 comma 18. Therefore my F will be equal to what? It will be equal to 118 comma 18 newtons. Okay, so that's how you are supposed to deal with this question, guys. That's how you are supposed to treat this question. I hope it makes sense, guys. If you didn't understand anything, just go back and hopefully you will get the understanding you need. All right, now we move on to 2.4. 2.4 says the angle that the plane makes with the horizontal is now decreased. How will this change the kinetic frictional force acting on block A? Choose increases, or rather choose from increases, decreases, or remains the same. Guys, the way in which we'll answer this question is to look at the relationship between our angle, which is this angle, we'll name it theta, and the normal force. And our relationship between the normal force and angle is what? Inversely proportional. We will also now look at the relationship between the normal force and our force of friction. And the relationship there, guys, is directly proportional. In this case, we're talking of kinetic friction. So here we are being told that our angle will decrease, and if my angle decreases, guys, with that arrow, it means that my normal force will have to increase, right? So when my normal force increases, I now have to check the relationship between the normal force and the kinetic friction. And you will realize that when the normal force then increases due to the decrease in the angle, then my friction will also increase, because the relationship there, guys, is directly proportional between normal force and kinetic friction. But we start at looking at the relationship between our angle and the normal force, and we are saying that the relationship there is what? Inversely proportional. So a decrease in our angle, this angle here, means we are increasing the normal force, and if the normal force increases, that means the kinetic friction will also increase. So the answer we will go for in this case will have to be increases. Okay, our kinetic frictional force will have to increase. And why does it increase? It's because of this reason that I've given here, guys. Because we are decreasing the angle, our normal force will increase, and since the normal force is directly proportional to the kinetic friction, it means our kinetic friction will increase. You will put it in words, guys. Yeah, and yeah, guys, that's it for this question. I hope you understood it. I hope you enjoyed it. And guys, if you benefited from the video, please give me a thumbs up, and of course share the video with the others. If you can also subscribe, that will be much appreciated, especially if you are in grade 11. Okay, see you on the next video, guys.